Welcome to Activity 11. This is a flip video and doodle notes on heat and energy. So this is focusing more on the different types of heat. We've already talked about the states of matter in the previous doodle notes, so we know about solids, liquid, gases, and how they can go from one state to another, and they can switch that through the application or addition of heat or taking the heat away. So we need to really understand what is heat. Heat is another word for the fancier, more scientific term is thermal energy. Thermal energy is more about how molecules move in a substance. So the more movement equals more heat. In science class, we like to represent different molecular structures in a very broad sense by having circles, and then we show the movement by adding these little lines. You see them in comic books, like Flash in a comic book will have a couple dashes after him to show that he was moving. So we do expect you to show movement by that. The more lines, then we're implying that you understand that there's more movement there. So energy itself, let's kind of go back, take a step back in time and talk about what is energy, because I don't know if you've formally been introduced. Well, energy meets students, students meet energy. Energy is the ability to do work. And in science class, work does not count like math test. That is work, right, to us? But in science class, that is not work. Work means to make something move. In high school, you're going to learn the very more scientific definition about it has to move in a very specific way. So we can measure the energy in your hand, right? Your hand has energy. This is a rough drawing of a hand. Whew, hands and faces are really tough to draw. Ask your art teacher. But if you put a thermometer in your hand, you will notice that the red liquid inside will rise. So that is causing, and that's proof that your hand has energy. And it's transferring that, and it's causing the red liquid to do work. The work there was rising and moving. So you're like, oh, well, even if I'm tired, do I have energy? And some of you act like you have no energy to do work. But inside your hand is stored energy with the molecules, and they are vibrating in place. And then that's causing that to expand. So let's talk about this heat stuff. So look at the box with pizza on it. So you got a nice yummy pizza crust. Let's go to Domino's maybe to get our pizza. And I want you to think about how heat moves. So heat itself moves to the cold areas. So heat goes to the coldness. If you leave this hot pizza out, and we need to show its heat, right? So we're gonna give it some red lines. I love nice hot pizza when those cheese is all gooey. It does get cold. So over time, the pizza gets cold. But how is that? Where does the heat go? Well, the heat tends to escape objects to the surroundings, to its surroundings. So heat always tries to balance out. So if this pizza is hotter than the environment in which it's in, so it's hotter than if this is I don't know, came out of an oven that was 350 degrees, that's clearly hotter than the surrounding kitchen, which would probably be in the 70s, right? So let's say 72 degrees Fahrenheit. So that heat's going to escape until they reach the same temperature. The world is all about balance. All the time in different scientific areas, that you'll notice that if the two tectonic plates are off balance, they're going to shift until there's balance again in the world. And it's the same thing with heat. If there's more heat in one area, this heat's going to transfer until the whole region is back in balance and it's equaled out. And since there is no such thing as cold, cold is just the absence or lack of heat. So cold can't move, only heat can. So your mama, she's kind of wrong when she says, close that refrigerator, you're letting all the coldness out. Well, no, she's kind of being dumb there because she's letting the heat in the refrigerator. There is no such thing as coldness. Really? Right? So the heat is just trying to balance it out with the refrigerator. So next time you leave your refrigerator open, you make sure you talk back to your mom and let her know that the cold isn't escaping, but the heat is entering. I'm sure she would appreciate that science lesson. So let's go over to this lovely oven. We're gonna make our oven pink because what kitchen would not be complete without a pink oven? Okay, it's a lovely oven. I need my red, but it dropped. Ugh. So the bottom is red. So if you want to heat that pizza back up again, you need to put it in a place that's now hotter. So to get more heat to your pizza, to reheat, you're gonna have to. Okay guys, so we just talked about heat and temperature, and we're going to go ahead and give you a gift of a skip for heat versus temperature. Okay, so this won't be on your assessment. There's no need to waste your lovely time on this, so draw yourself a happy face emoji instead. So turn your paper over. My side's blank, but your side looks like this. Now this is what you will see a huge portion of your summative on 3 different things. Thing 1, called conduction. Thing 2, convection. And thing 3, radiation. So we're going to go over each of those and a couple examples of those. Okay, so conduction. Conduction is one way to transfer heat. So we were talking about 3 ways to transfer heat. And this is transferring heat through direct contact. So I kind of want you to like underline the D, direct contact. So conduction, the one with like the D in the middle of the word, conduction has direct contact. So I want you to make that connection together. So this happens often with solids. So let's say this is some sort of metal. Metals have their atoms tightly packed together, which just makes them such a strong substance. And so if this is a metal, like a metal spoon for instance, and you hold the metal spoon over a fire, what you're actually causing to happen is the already tightly packed atoms that jiggle and they vibrate in place, you're causing those to vibrate even more rapidly. So as you add heat, you're increasing the amount that they are vibrating there in place, and that then causes a domino effect as the heat is transferring over to the neighboring atoms. So you put a spoon over fire, that spoon's going to get hot, obviously underneath or right above where the fire is, and then the neighboring area is going to get hot until the whole entire spoon is going to be too hot to touch. So that happens, it transfers heat by vibrating atoms next to each other. So let's give you 3 examples of things that get hot through conduction. Number 1, when I cook, I put my pots and pans on the stove. So it's directly on the stove. And then they get hot through that way. Number 2, I use a flat iron. Sometimes, not all the time. When my hair is flat, I use a flat iron. And that's through direct contact that I am touching that hot surface to my hair. And that is transferring the heat from the flat iron to my hair through direct contact. And number 3, I'm going to say touching a grill. I'm not saying grill like Flavor Flav's teeth grill. I'm talking grill like if you touch a barbecue grill, you can get yourself burned. My cousin touched the motorcycle once after her dad rode it for like an hour. Dad said, don't touch the motorcycle. Little cousin Lisa touched the like the radiator section and burned her hand. So through conduction, that heat transferred from the motorcycle to her hand, and she had a huge blister all over her hand, and she cried forever. I mean, I imagine it hurt, so it makes sense she cried forever, but she shouldn't have touched it. That was kind of foolish. Okay, so conduction. Look for the D for direct contact. Now this word looks very similar, and if you read like I do, I only read the beginning and the end of the word, you gotta pay attention to the middle, because now we're on convection. Convection is something completely different than conduction. Convection is when heat is transferred, I don't want to use convection, through movement, I'm going to say. You might have heard convection currents, but here is an example. My daughter, I'll give 3 examples, oh maybe not 3, 1 or 2 examples. My daughter has a bunk bed. In the summertime, the top bunk is hotter than the bottom bunk. So have you ever heard the phrase that heat rises? And that is a true statement, it's scientifically sound. So the heat is less dense and it will rise up in the atmosphere or in the bedroom. So if you have a bunk bed and it's the summertime, you're going to notice that top bunk is hotter, noticeably hotter than the people at the bottom bunk. So another example would be if you have like a 1-story or on your 2nd story house. So my grandpa lived in a apartment, and he was in the first level. So in the summertime, that's really nice because the heat rises. So his apartment stayed relatively cool, while the apartments above him, the second and third floor, they would get hotter. So if you have a 2-story house, or if you notice if you had a basement versus upstairs, the basement's going to be cooler because the heat does rise. Any other examples? Mr. Mills, can you think of an example of heat rising?
Well, convection through water.
So let's look at this picture here.
That's it.
Okay, so this is my little fire down here. It's beautiful. And, oh yeah, I know. And then you got a pot here, and then there's some water inside. So maybe we're cooking up some ramen noodles, gourmet dinner there. And so the heat, the water is going to start heating up down here near the fire source. And then as it gets hot, it is going to rise. But you know what? As it rises, it's touching the air up here, which is cooler than the fire. So then it's going to cool off, and it's going to lower down. And guess what? It's by the fire, so it's going to get hot, and it's going to get less dense, and it's going to rise up. It's going to cool off because it's near the air, then it's going to fall down. That, my friends, exactly is what's called convection currents. If you've ever heard of a convection oven, it causes a cycling of air, and it spreads the air around inside the oven. Meteorologists will also talk about convection currents. Apparently they're important to weather. I don't know why, but they are. So, number 1, to transfer heat, conduction, direct contact. 2, convection, and convection is the movement. So try to think of arrows here in the movement of either air or water. It has to be between a liquid or a solid, liquid or a gas. Solids won't do convection because they don't have the ability to move. So you might be wondering, what is this weird picture over here? Okay, so this paper is on fire, and it's smoldering. Okay, so you have a smoldering paper. Smoldering means smoking. That smoking paper is causing smoke inside of this box here. And this box is called a smoke box. Very scientifically named, but that's what they call it. And as this fire at this candle here heats up the air, it's causing that smoke to rise. So the smoke will settle, then the smoke rises again. So it's in a science class, in high school, you may see like a smoke box where they cause convection currents, and they were able to illustrate it by using smoke. Okay, last one, radiation. I appreciate this one doesn't start with a C, and it helps us remember it from the other ones. So radiation, draw some lines out from it. Have you ever been told that you radiate happiness? If you have, it's kind of a nice compliment. So radiation is when something, actually everything, gives off, we're going to say, thermal energy. Now, my friends that are gamers...
Like Fortnite?
Oh my gosh, like Fortnite. Mr. Mills is a good boy for knowing Fortnite. So, if you're a gamer and you're playing like Black Ops or something and you're shooting things at night, you're going to put on a thermoscope. And that will look for this radiation, the heat energy that's being emitted or released from every single object. So everything is going to radiate. Your bodies will, a metal will, tables will, grass will, everything's radiating, but it's a different amount of heat. So a living organism like a human that you're trying to shoot in your game is going to like shine brighter because they have more heat there. So a main source of radiation in our world is called the sun. I hope you've heard of it. And every single day for the last million years, it has been radiating heat to all of our solar system. Without that, we would not have our life, clearly. So it's coming all the way over to Earth. And it travels as waves, which we studied the last unit. So this is an example of radiation from the sun. Okay, so we may have talked about this in the last standard. I honestly don't remember. But you have different types of objects will radiate different amounts, and then we also have different types of objects will absorb different amounts of heat. So we talked about how the black pigments will absorb and become hotter than their white friend counterparts. So dark objects do absorb heat, and then the light objects absorb less. But I want to go ahead and list, just like we did list some examples, I want to list other examples of things that radiate heat. Okay, so things that give off heat. So one example is like a fire pit. With these nice cool evenings, it's kind of a good opportunity to go outside and have your parents light the fire pit and sit around, maybe roast some marshmallows. Think about 6th grade camp when you were around the campfire. So maybe just put a sash there, campfire. And those are times where they have radiated. You did not touch it through conduction. And there might have been a little convection going on, they may not noticeable, but there was mostly radiation as the fire emitted that energy to you. Another example of radiation would be the lovely sun emitting light all the way to us, light and heat. And then the third example...
Gamma radiation, which changed Bruce Banner into the Hulk.
Okay.
It radiated gamma rays out.
So then there was gamma rays hitting Bruce Banner, turning him into the Hulk.
That happened to me once.
It did. It was not pretty. He did not turn green. He was purple. Okay, so you have 3 types of transferring heat. You got conduction, which is direct contact. You got convection, which is the movement. And then you got radiation, which is like emitting and releasing the heat from an object. So I expect you to be able to understand the definitions of the 3 and be able to give examples or identify examples of the three. Okay, if you have any questions, as always, go see somebody else. Have a good day.